Welcome back. We're going to talk about section 8.1, which is maybe not helpfully titled non-right triangles. So let's just talk about a non-right triangle. Let's see if I can draw a non-right triangle. Okay. Well, I could. Yeah, okay, we'll call it that. Now what we're going to do is we're going to label our angles with Greek symbols. So I've got alpha, I've got beta, and I've got gamma. And by convention, we label the side of the triangle that is opposite alpha, A, the side that is opposite beta, B, and the side that is opposite gamma, C. Now, alpha and beta probably make sense to you because they kind of sound like A and B, but why gamma and C? Well, turns out gamma is the third entry in the Greek alphabet. C is the third entry in the English alphabet, so A, B, C. All right. So now I'm going to develop something called the law of signs. And I'm going to show you where this comes from so it doesn't look like magic. So let's drop a vertical through this, and we're going to label this H. So now we can see I've got two right triangles. I've got a right triangle here, and I have another right triangle here. The thing they share is that vertical that I dropped, that hypotenuse. Also note that H, the H is not hypotenuse, H is just height. Okay, also note that the hypotenuse of each right triangle is a side of the original angle. So looking at just the blue right triangle, the sine of alpha is H over C. Now looking at the pink right triangle, the sine of gamma is H over A. So if we rewrite each of these things, that means that H is equal to C sine alpha, and H is equal to A sine gamma. Well, H is H, so that means that C sine alpha is equal to A sine gamma. And this is going to quickly lead us to the law of signs. Because if I put the A and the alpha on the same side and the C and the gamma on the same side, so I'm going to divide both sides by A and divide both sides by C. And what I end up with is sine alpha over A equals sine gamma over C. And it turns out that it doesn't matter. I could do this for any angle. So I dropped my vertical from beta, from angle beta. I don't have to do that. I could drop my vertical from angle alpha to make a perpendicular over here, and I would come up with a very similar response. And in fact, it turns out that if you do that for all three triangles, you find that the sine of any angle on my triangle divided by the length of the side opposite is going to be equal for any angle in any triangle. This statement here is called the law of sines. And we are going to use this law of sines to solve problems, and we'll come back and do that in the next video.